JavaScript is crazy. I mean, there's so many different wild features and properties out there, it's pretty much impossible to know them all. But in this video, I'm going to be sharing with you 5 unique features that I'm guessing you probably don't know, but could be incredibly useful. And also, if you want to take your JavaScript skills to the next level, I just finished my full JavaScript beginner and advanced course. It's just under 40 hours of content and covers everything from the most basic things about JavaScript all the way up to advanced things about JavaScript and programming in general that I didn't know until long after I landed my first job. And if you're interested in checking that course out, you can use the discount code EARLY to get 20% off as long as you do that within the first week or so of this video coming out. It'll be linked down in the description below for you to go check out. I highly recommend it. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now, the very first thing I want to talk about is the thing that you saw in the thumbnail, which is essentially how you can use labels. And these labels are generally used inside of loops, but we'll get to how they can be used inside of scope, which is what the thumbnail was all about. So this really simple example here, we have 2 different for loops. We're looping from 0 to 4 here, so essentially 0 to 3. And then for this for loop, we're looping between 0 and 2. And then down here, we're just printing this out. And as you can see on the right side of the screen, we have I and J being printed out. So we have I0, J0, and then we have J being incremented, I being incremented up here, and just so on all the way down through the list. And if you're a little bit confused on how the styling and stuff works inside this console log, you're going to want to check out the first video I did in this series. I'll link it up in the cards and description for you so you can see exactly what I'm talking about. But let's say that we want to skip when we get to I equals 1. So you may normally say, okay, well, if I is equal to 1, then what we're just going to do is continue. This allows you to skip one iteration of the loop, and you may think that this will work. And it's going to look like that worked. As you can see, we have I being printed out for 0, 2, and 3, but nothing for I equals 1. But we're still running this for loop a bunch of times. If I just put a simple console.log in here, where I just say before, so this is running before our check, you're going to see that if we come up here, we have before being printed, then our print, then before, and then our actual print, until we get down to here where I equals 1, and it's printing out before 4 separate times, and then it's continuing on as before. And that's because we're just continuing every time I equals 1, which means we're looping through this for loop some extra times that we don't need to. What I would like to do is just if I equals 1, stop executing everything inside this J for loop and just increment my I. Well, to do that, I need to use a label. So let's just label these different for loops. We have this one, we're going to call loop 1. And to make a label, all you do is just type in the name of the label that you want, just like a variable name, for example, put a colon afterwards, and then a space, and then there we go, we have our for loop labeled. Same thing for this one, we're going to call it loop 2. And now what I want to do, instead of just doing continue, I want to continue loop 1. And what this essentially says is, okay, exit me out of loop 2 completely, go up to loop 1 and increment the number by 1 and continue, just like you would do with a normal continue statement. So now if I save this, you're going to notice here I get before and then everything being printed out. And now here, instead of before being printed out a bunch of different times, 4 different times, it's running this for loop one time where it's saying console log before and then I equals 1. So it exits out completely and goes back up to the top of this for loop. And then it comes into this for loop again, prints out console log before, and then prints this out. So by using this continue statement with a loop label, we can immediately skip out of this loop into the top loop. And this is really great if you have nested loops and you just have one condition that you want to check and you say, you know, if this condition is true, just exit me out to the very top in the next loop. Another way to see this a little easier is if we move this if check after our console log like this, what we can do is just save this and you'll see that we get it being printed out for 0. And then when we get to I equals 1, it prints it out the first time it goes through, and then we're continuing, so it no longer prints this out anymore. But if we were to change this where we just did a normal continue without the continue loop 1 and save, you can see it still prints out all those different values for I equals 1. And that's just because it's just continuing and not allowing this inner loop to run anymore. It'd be the same as if we said continue loop 2, because that's the loop that we're currently in. But we wanted to continue loop 1, which is why we wrote continue loop 1, and it exits us out of this middle inner loop and immediately increments us to the next value in this upper loop. This is a pretty strange scenario to run into where you would want to do this, but there's certain scenarios where you have nested loops like this, and the inner loop, you have some condition that you want to check, and if it's true, you want to move on to the next value of your outer loop. And you can imagine you had multiple levels of nesting, maybe 3, 4, 5 different loops deep, and on the very most inner loop, you want to just skip to the very next value of the outer loop. So using these labels allow you to do that really easily, because we can just say, okay, continue this loop right now. Or instead of doing continue, we could also say break. So break will normally exit you out of the loop that you're in, but if we say break loop 1, is this going to exit us out of loop 1 completely? So if we save, you can now see once it gets to that I equals 1 value, it prints it out, and then down here it's saying, okay, well I equals 1, so we're going to break out of loop 1, which means we completely exit out of this outer for loop, and if we just did a normal break, and save, you can see it's just breaking us out of this loop 2 on the inside instead of breaking us out of the outer loop. So by using these labels, we can really easily specify what loop we want to break out of. Now, something else that we can do with labels is actually label any scope block that we want. So for example, we just make a generic scope by typing in these curly braces. And if you're not familiar with how you can just create a scope anywhere you want, you're going to want to check out the second video I did in this series. I'll again link it in the cards for you. But we can just give this any name you want. For example, name. And inside of here, we'll just say console log before. Do another console log called after. And if we just run this, you can see it prints out before and after because we just have a scope and the scope runs and it just allows us to scope these variables. But we named this scope with the name of name. So now what I can do inside of here is I can just say break and I can pass it the name of my labeled scope here, which is name. And now what happens is you can see it just prints out before and then it exits me out of this entire scope here. And I can put another console.log here that says after scope. And as you can see, it says before, and then with this break here, we're breaking out of this entire scope, and it just goes down to this code down here. While without this here, we're printing out before, then after, then logging out after scope. Now, the second topic that I want to talk about is one that you're probably familiar with, and that's if you create an object or an array using const, and then you try to change a property of that object, it'll actually change it. As you can see, we create this constant person with the name of Kyle. And as you can see, when we print this out, the name is Kyle, and then we're changing the person's name to John, and then we print it out again, and the name is John. And initially, when you first see this, you're probably confused because, const should be creating a constant object, but it doesn't. And if you're unfamiliar with why this is and why you can actually change properties on these objects, I've already done an entire video on it. I'll link in the cards and description for you, but that's not what I'm talking about at this point because most people already understand that. What I want to talk about is how you can actually make it so it's impossible to redefine the properties of an object. And that's by using something called Object.freeze. So if we just take object here, we can call a method freeze on it, and we just pass it in an object. And what this does is it makes it so you can't change any of the properties of that object. So if we save now, you're going to notice that it still prints out Kyle for both of these. The name is Kyle here, and the name is Kyle here, even after I try to change it to John. And if we're in strict mode, so if we just come up here, and we say use strict, and we save this, you're going to notice we actually get an error and it just says cannot assign to read-only property name of object. So if you're in strict mode, it's automatically going to throw an error. And if you're not in strict mode, it's just going to not allow the actual change to be made. Now, Object.freeze is great for making it so you have an immutable object. But if you have a nested object, for example, we have an address inside of here, and this address has a street, which just says 1, 2, 3, 4. What we could do is we could say person.address.street, and we could change their street to 5, 6, 7, 8 instead. And now when we look at the person, their address here is going to be 5, 6, 7, 8. So it allowed us to actually change this nested object. And that's because Object.freeze only prevents you from changing the initial properties on the object. So name, age, favorite food, address, but it doesn't deal with any of these nested objects. So we'd also need to do an Object.freeze on this nested object as well. And once we do that, you're going to notice if we check here, the street is now no longer changed. It's still 1, 2, 3, 4 since it didn't allow us to reset it. And again, if we were in strict mode, it would throw us an error. This is incredibly useful if you're doing any type of functional programming because you don't want to mutate anything when you're doing functional programming. So making sure you have Object.freeze on all your objects means that it's impossible to mutate those different objects. Also, something else you can do with Object.freeze is do arrays. So I could just say, you know what, my array here is going to be hobbies. And I'm going to just put in some hobbies here. So we're going to have like weight, lifting, and let's just put in bowling. There we go. And I just want to say, you know what, hobbies dot push. And I'm going to push in a new hobby here. And this new hobby, we're just going to say is whatever. Now, if I look, you can see that these hobbies have been changed. I now have 3 things inside this hobbies array. But I can use Object.freeze, and it'll prevent me from changing this array at all. So by doing this, you can see cannot add property to object is not extensible at array.push. It's essentially saying this array here is frozen. We can't change it. The nice thing about Object.freeze is we can use it on arrays or objects. They both work. And essentially saying you can't push to it, you can't remove from it, you can't modify it. It's frozen in place. You cannot change it at all. Now this next one is actually going to be a bit of a two-parter, so you kind of get a bonus. And that's because we're going to be talking about maps and sets. And they're both very similar and serve similar purposes for what they do. So the first thing I want to look at is the traditional way that you would create a map in JavaScript, and then I want to show you the actual way that you should do it. So let's say here that we have a map that maps a country name here to the currency used in that country. And just imagine that there's, hundreds of items inside of this map because you have some giant picker that the people can choose what country they're from. And then let's just say I chose United States as my country. So it's saying my currency is USD, and we're printing that out to the screen. Pretty standard stuff that you've probably used all over the place. But this has quite a few downsides to it, in that it's not the most efficient way to do something like this. And it's kind of difficult to loop through all these different currencies. If I wanted to like print out a list of these currencies, it's really hard to do that with an object. So instead, what I want to do is convert this to use a map inside of JavaScript. So let's just say we want to redefine this. We're going to create our currency map. We're going to set it to a new map. Let me just comment this out up here. And now we have this map object. And the map object, when you first create it, can either be empty like this, and it'll create a brand new empty map. And if we just do a quick console.log of our currency map, and I get rid of this other code down here, we can see we just have an empty map with nothing inside of it. And if we want to, we can actually pass it an array of arrays. So if we wanted to put United States in here, we'd pass it an array, and the first array inside that array would have the value United States as the first property, and the second property would be its value, which is USD. And then we could put in here India as well. So we could say India, and we could have rupee in here. And now if we save, you can see we have a map with two entries, United States, which maps to USD, and India, which maps to rupee. So this is how we would create the map, but let's say that we left the map empty to start with. We could also just say currency map.set, and this allows us to set an entry. So we could say, you know what, for the value United States, I want to set the value here of USD. And now you can see our map has that value key relationship inside of it. And the really nice thing about these maps is you can do so much more than just do a key value of like a string to a string. We could actually use an object here. I could say, you know what? I want the object that has the name of United States to be set to that property. This is something you cannot do with a normal object-based map up here. I took an object, and now I'm referencing that object. Whenever I pass this object to this thing, I'm going to get the value USD out of it. So as you can see, we now have an object as the key. If I take this object and I just pull it out into a variable, we're just going to call USA is equal to that. Then I use USA here as the key. What I can do is I can just say, you know what, I want to do currency map. I want to get the property for that USA key. As you can see, it prints to us USD, which is the value we assigned to this object. This is super, super useful because we can not only map strings to things, which we could do in normal objects, but we can also map things such as objects, booleans, numbers, whatever it is that you want to do a map for. Also, on top of that, it's really easy to loop through a map because we can just say currency map.forEach, and it's going to loop through each one of our key value pairs for us, while with an object, it's much harder to do that. And that's pretty much all there is to maps. These are just really useful anytime you want to map between one value to another value, whether that's from an object to a string, from a string to a string, whatever it is. And the next thing I want to talk about is sets, which are very similar, but they're for arrays. Maps are for objects, and sets are for arrays. So let's just say we have an array, which we'll call unique numbers. And we're just going to say here, it's going to have some numbers inside of it. And you'll notice we have a duplicate. We have 234 showing up twice inside of here, but we want to make sure this is an array of unique numbers. Well, that is where a set comes in. What we can do is we can just say a set here. We'll just say const set equals new set. And we're going to set it equal to those unique numbers. And then we're just going to console.log out our set to see what it looks like. And you'll notice our set only has the values 1, 2, 3, 4, and 45. It got rid of the duplicate value of 234 here. It's only showing us the values that are unique. And that's because a set is very similar to an array, but it only allows you to have unique values. So anytime you try to add a value to a set that already exists, it just ignores it completely. And the nice thing about sets is it makes it really easy to add values and remove values, while with an array, it's kind of hard to remove a value from an array because you have to fill in the gaps and all of that. But with a set, it's super easy. We can just say set.has, and we can just say, okay, you know what, does it have the value 1? Let's just do a quick console log here. For set.has1. Okay, yep, it has the value 1. We'll say, does it have the value 2? Nope, it doesn't. We could say that we want to come in here and we want to delete the value of 1. And then we'll do a quick console log of our set. And as you can see, it prints out our set and it no longer has the value 1 inside of it. So as you can see, this is really useful for dealing with arrays where you have unique values inside of it, which happens all the time when you know you have an array of completely unique values. And the next thing I want to talk about is something that you've almost certainly seen before, but maybe don't quite understand why exactly it is an issue. So as you can see here, we're just console logging 0.1 plus 0.2, and we're getting 0.300000004. And you've probably seen this as a meme all the time. Like people are like, oh, JavaScript is a terrible language because whenever you add 0.1 and 0.2, you don't get actually 0.3. But what most people don't realize is this is not a problem with JavaScript per se. This is actually a problem more so with how computers actually do math and the limitations of computers when it comes to doing floating point arithmetic, which is essentially any type of math that involves decimal point numbers, so numbers that have a decimal anywhere inside of them. Now, the reason for this type of error is because for a computer to do actual arithmetic, they need to convert all of the numbers into binary. And when you convert 0.1 into binary, it actually is an infinitely repeating value. It's the same thing as if you do 1 divided by 3 inside of decimal math. This is just the same as 0.33333 forever and ever repeating. Well, 0.1 in binary is very similar to, 1 divided by 3 in decimal. It's an infinitely repeating number. Same thing with 0.2. And a computer can't represent an infinitely repeating number. That's impossible to represent. So they represent it about as far out as they possibly can for both of them within the limits of storage. And then they do the actual operation and then try to convert that back into a decimal number. But when you take a value like 0.333333, you only have so many 0.3s you can do. And when you try to add that to, 0.6666666666666 instead of decimal, you're not going to quite get 1, even though if you do 1 divided by 3 plus, 2 divided by 3, that'll always give you 1 because you know that's going to be 1. But when you try to convert it to a decimal format like this, they just repeat forever. That's the same thing with 0.1 and 0.2. They repeat forever inside a binary, so when you try to add them together, you're never going to get the perfectly accurate answer. And that's the problem with computers and floating point numbers like this, is when you do the conversion between decimal and binary and back to decimal, you're going to have some rounding errors. I mean, as you can see with this, it's very minor, and a lot of times when you do operations, these numbers are going to come out exactly as you would expect. Well, let's just come in here and we'll just change this to 0.4, and now you can see we get 0.5 exactly. But the thing to keep in mind is that you're not always going to get the exact same answer because of this conversion factor, which is why if you're doing things where you're taking, an if check and you're saying, if variable x is equal to the value like 0.35, this is generally a bad idea because this floating point arithmetic could be 0.35 or it could be 0.3506 like this. And you don't really know that. So what you need to do instead is if you're like constantly adding values, you want to check when x gets up to the value of 0.35, instead of doing an equal check, do like a greater than equal to check right here. This would be what you would want to do instead. If like inside of a loop, you're just adding values to x over and over and over again, you want to check to see if it's greater than or equal to 0.35, because based on that rounding, you could get a slightly higher value than 0.35 or a slightly lower value than 0.35. Another thing that you could do is you could say, I want to check to see if it's greater than less than or equal to this 0.35005. And I want to check to see if x is greater than or equal to, and we'll do 0.3499995. Just some level of error right here. So we can say, if it's in this margin of error, then we're going to assume it meant to get 0.35. So we're allowing the computer to do its rounding and be slightly off. And for the most part, it won't be more off than these types of values. Like usually when this floating point arithmetic is off, for in the example of 0.1 plus 0.2, it's off by a very, very small fraction. So we just need to make sure we account for the fact that these things could be off. So generally, if you're doing any type of check where you're checking one value equal to another and that value is a decimal number, you don't ever want to really use these equal equalities because most likely this is not going to land exactly on 0.35. It might be slightly off. Now for this last topic, I want to talk about a few different debugging tips that most people don't realize you can do inside of the console. So let's say here we have a really long function that takes a while to run. As you can see, when I save this, it prints out before, and then it takes a little while until after it prints out because this loop takes a long time. Just imagine this is like a slow running function, and you want to see how slow this function is. Well, one thing you could do is put a before and after in here and just kind of like mentally look at how long it takes. The problem with that is, it's very inaccurate. You have to mentally look at it, and it's just not a good option. So instead what you can do is you can use something called console.time. With console.time, you just call console time when you want it to start, and you give it a name of whatever you want this timer to be. We're just going to call this timer. And then you come down when you want the timer to stop, and you say time end, and you give it the same name. So in our case, we give it the name of timer. And now what happens is it tells us how long it takes between when we first call console time and when we call console time end. As you can see, it took 512 milliseconds for this for loop to run and do nothing essentially, because it's just looping through itself a bunch of different times. So using console time is a really easy way to see if you have some performance issues in your application. If you notice things are running slowly, what I would recommend doing is putting a console time and a console time end in between the code that you think is going to be running slowly. So you put it at the start of the code and at the end of the code, and then you see, is it slow? If it is, then what you do is you kind of narrow down your console time. So let's say, for example, we have a bunch of code up here, and we have a bunch of code down here, and we know somewhere in this code that it's slow. So we put our console times at the edge like this, we run it, and we say, okay, you know what, this is pretty slow. So then we start moving our timer in, and we say, you know what if we do our timer here? And we run it, and you say, okay, you know what, it's still pretty slow. So let's say we move this timer up, and now we save, and you say, okay, you know, it's still pretty slow. And then we realize, well, there's only one thing left in between our timers, which is this. So this must be the thing that's making it slow. And if for some reason, we moved our timer all the way up here, and we had some this code in between it, and we saved, and went, oh, you know what, this is still running pretty quickly. So it must have been when the timer was down here earlier. So it's a really good way to narrow down where the performance issues inside of your code are by using console time and console time end. Now, something else I want to talk about is right here. Let's just say that we have some code where we're saying x equals 2, and if x doesn't equal 1, then we're going to log out some type of error. Console log x is not 1. And if we save, you can see it prints out x is not 1. Well, one way we can immediately improve this is by using console.error instead of just console log, and that way it'll print it out in red, letting us know this is an error. Or we could do console.warn if we wanted this to be a warning, but in our case, we want this to be an error. So what we're doing is essentially asserting some value, and then we're logging something out. Well, console actually has something built in to do that. It's called console.assert. And what we can do is we can pass it a thing that we want to check. And if this thing is false, then it's going to print out whatever we want. So we can say, okay, we want to make sure that x is equal to 1. So I want to assert that x is equal to 1, which means if x is not equal to 1, I want to log out whatever I put here, which in our case is just going to be x is not 1. So now I've replaced the code right here, which has this if check and the console error, and I've replaced it with this console assert where I'm saying I'm asserting that x is always going to be equal to 1. And if it's not, I want to print this error out. And as you can see, assertion failed, x is not 1. Well, if x is now 1, you can see it doesn't print anything out at all. So this is a really great way to condense that if check that we had before to just say, okay, assert that x is equal to 1. If not, print out whatever we put here. Now, the final major console thing I want to talk about is if you're consoling out an array. Let's say we have an array of people here. We have name Kyle, name John, name Sally, and I'm printing those people out. And as you can see, I can see these values, but it's kind of hard to compare these different values to one another. So instead, we can use something called console.table. What this does is it takes our array and it takes all the values inside of that array and converts them into this table format. So you can see we have at index 0, name Kyle, age 25. Index 1, we have here name John and age 33. And it's really easy to compare. Okay, you know what? We have name here, we have age. We can even sort these different properties if we want. You know, I'm going to sort by the age, or I'm going to sort by the name here, for example. So it's really easy for us to be able to compare the different values and properties between all the different things inside of our array. Instead of doing, this where we have just our array being printed out to us, this makes it much harder to do this comparison. While with this, we can just, really easily sort things, compare things back and forth. It's super nice. Now, the final tip related to debugging I want to talk about is you can just type the word debugger anywhere in your code, and when your code runs and hits this point, this debugger point, it's going to pause your script immediately, and it's going to say, okay, we're right here, we're paused, and we can access variables. I can see the people variable here. I can see the stack trace over on the side here. I can see things such as my scope. So I can see, my scope has this people variable inside of it. And in my console, I even have access to all the variables at that point, for example, people. So this is really useful for just being able to debug your code exactly where you are. And if we go back to that sources tab, we can actually step through our code line by line. I'm going to step to the next line, step to the next line, and so on. And that right there is 5 amazing JavaScript features. If you enjoyed this video, again, I highly recommend that you check out my full JavaScript simplified course. It'll be linked down in the description. And if you get to that course within the first week of this video going live, use the code early and you're going to get 20% off the course that you buy. So I highly recommend you check that out as soon as possible so you don't miss out on that discount. Thank you very much for watching and have a good day.